Hello and welcome. Today my team and I are going to present you the proxy design pattern. Proxy is a structural design pattern that lets you provide a substitute or placeholder for another object. A proxy controls access to the original object, allowing you to perform something either before or after the request gets through to the original object. Structural patterns explain how to assemble objects and classes into larger structures while keeping this structure flexible and efficient. The question is then, why should you want the access to an object to be restricted? For example, your application depends upon a very large object that consumes a lot of system resources, but you only need it from time to time, not always. You could implement lazy initialization, create this object only when it's actually needed. All of the object's clients will need to execute some deferred initialization code. Unfortunately, this would probably cause a lot of code duplication. In an ideal world, we'd want to put this code directly into our object's class, but that isn't always possible. For instance, the class may be part of a closed third-party library. The solution that the proxy pattern suggests is that the creation of a new object with the same interface as the original object is necessary. The original object's clients are updated so that all their requests now pass through the proxy object. Upon receiving a request from a client, the proxy creates a real service object and delegates all the work to it. The proxy disguises itself as a database object in this example. It can handle lazy initialization and result caching without the client or the real database object even knowing. So what's the benefit? If you need to execute something either before or after the primary logic of the class, the proxy lets you do this without changing that class. Since the proxy implements the same interface as the original class, it can be passed to any client that expects a real service object. And now let's see a real-world analogy. The problem with cache is that if you have lots of it, after a while it will become cumbersome to carry it around all the time. So you open a bank account and you store all your money there. But how can you make payments now? The bank provides you with a proxy in the form of a credit card, which is the proxy for your stored cash. This works because both the credit card and the cash are used for the same purpose, payments. We can say that they both implement the same interface with the method pay. A shop owner is also happy since the income from a transaction gets added electronically to the bank's account without the risk of losing the deposit or getting robbed on the way to the bank. Now let's see the theoretical structure of this design pattern. The service interface declares the interface of the service. The proxy must follow this interface to be able to disguise itself as a service object. The service is a class that provides some useful business logic. The proxy class has a reference field that points to a service object. After the proxy finishes its processing, for example, lazy initialization, logging, access control caching, etc., it passes the request to the service object. Usually, proxies manage the full lifecycle of their service objects. And lastly, the client should work with both services and proxies via the same interface. This way, you can pass a proxy into any object that expects a service object. And now, let's see how can we implement with some pseudocode the previously talked about structure. Here we can see a UML diagram that looks exactly like the theoretical structure talked about before. Here we find the interface of a remote service and the concrete implementation of a service connector. Methods of this class can request information from YouTube. The speed of the request depends on a user's internet connection and as well as YouTube's. The application will slow down if a lot of requests are fired at the same time, even if they all request the same information. So we implement the cached YouTube class. To save some bandwidth, we can cache request results and keep them for some time, but it may be impossible to put such code directly into the service class. For example, it could have been provided as part of a third-party library and/or defined as final. That's why we put the caching into a new proxy class which implements the same interface as the service class. It delegates to the service object only when the real requests have to be sent. And lastly, we have the YouTube Manager and the application class. The GUI class, which used to work directly with the service object, stays unchanged as long as it works with the service object through an interface. We can safely pass a proxy object instead of a real service object, since they both implement the same interface. and the application can now configure proxies on the fly. Now let's talk about some applicability and the pros and cons. There are dozens of ways to utilize the proxy pattern. Let's go over the most popular ones. Lazy initialization or virtual proxy. This is when you have a heavyweight service object that wastes system resources by being always up, even though you only need it from time to time. So, instead of creating the object when the app launches, you can delay the object's initialization to a time when it's really needed. Access control or protection proxy. This is when you want only specific clients to be able to use the service object. For instance, when your objects are crucial parts of an operating system and clients are various launch applications, including malicious ones. So, the proxy can pass the request to the service object only if the client's credentials match some criteria. Local execution of a remote service or remote proxy. This is when the service object is located on a remote service. In this case, the proxy passes the client request over the network, handling all of the nasty details of working with the network. Logging requests or logging proxy. This is when you want to keep a history of requests to the service object. The proxy can log each request before passing it to the service. Caching request results. Caching proxy. This is when you need to cache results of a client request and manage the lifecycle of this cache, especially if the results are quite large. The proxy can implement caching for recurring requests that always yield the same results. The proxy may use the parameters of requests as the cache keys. Smart reference. This is when you need to be able to dismiss a heavyweight object and once there are no clients that use it. The proxy can keep track of clients that obtain the reference to the service object or its results. From time to time, the proxy may go over the clients and check whether they are still active. If the client list gets empty, the proxy might dismiss the service object and free the underlying system resources. The proxy can also track whether the client had modified the service object. Then the unchanged objects may be reused by other clients. Pros. You can control the service object without clients knowing about it. You can manage the lifecycle of the service object when clients don't care about it. The proxy works even if the service object isn't ready or is not available. And the open-closed principle. You can introduce new proxies without changing the service or clients. And some cons. The code may become more complicated since you need to introduce a lot of new classes. The response from the service might get delayed. And finally, let's see some guidelines on how to implement the proxy design pattern. If there's no pre-existing service interface, create one to make proxy and service objects interchangeable. Extracting the interface from the service class isn't always possible because you'd need to change all of the service clients to use that interface. Plan B is to make the proxy a subclass of the service class, and this way it'll inherit the interface of the service. Create the proxy class. It should have a field for storing a reference to the service. Usually, proxies create and manage the whole lifecycle of their servers. In rare occasions, a service is passed to the proxy via a constructor by the client. Implement the proxy methods according to their purposes. In most cases, after doing some work, the proxy should delegate the work to the service object. Consider introducing a creation method that decides whether the client gets a proxy or a real service. This can be a simple static method in the proxy class or a full-blown factory method. Consider implementing lazy initialization for the service object. And that's all for the introductory part, and now my colleagues will present you with some real-life examples. Thank you.
Hello, this is an example of the proxy design pattern being used in the Spring framework in the context of the transactional annotation. Because one of the main drawbacks of the proxy design pattern is that it adds a lot of classes, I'm going to show you only the proxy class that is created and so debunk the magic that is behind the transactional annotation proxy. At a high level, when a class declares transactional on itself or its members, Spring creates a proxy that implements the same interface as the class you're annotating. In other words, Spring wraps the bean in the proxy and the bean itself has no knowledge of it. A proxy provides a way for Spring to inject behaviors before, after, or around method calls into the object being proxied. Internally, is the same as using a transaction advice using aspect-oriented programming, where a proxy is created first and it is invoked before or after the target bean's method. The generated proxy object is supplied with a transaction interceptor, which is created by Spring. So, when the transactional method is called from the client code, the transaction interceptor gets invoked first from the proxy object, which begins the transaction and eventually invokes the method on the target bean. When the invocation finishes, the transaction interceptor commits or rolls back the transaction accordingly. So, here we have the transaction interceptor provided in the transaction proxy factory bean. Also, we have this point cut, which is a method matcher which will be used in the proxy creation method. As we can see here, if the point cut is different from null, then we return a default point cut advisor, which will then intercept the transaction. Otherwise, we will rely on the default point cut and continue with the transaction attribute source advisor. Also, I have bootstrapped a small Spring application to demonstrate this behavior. Here we have an entity class for the example. Here we have an interface in which we declare a method create. The method create is then implemented in the account service implementation using the entity manager where we want to persist. Also notice how here we have used the transactional annotation. Okay, for the testing part we have two methods. In the first method, where we don't supply the application context with no transaction config file, when we create a bean for the account service, we will see that if we check the name of the class that is created, we will see that the class which we implemented is going to be generated. Okay, going to the next example, we see that here we supply the application context with a transaction config file. Therefore, the point cut will not be null, and when we create the bean for the account service, we will see that a dynamic proxy generated by Spring using JDK reflection API is going to be created, and therefore we are going to use the proxy on the method that we have used the transactional annotation on.
Let's look at an example that uses the proxy pattern for lazy initialization. This is from the Entity Framework source code. Here we have the lazy internal context class, which acts as a proxy to an object context instance. This is helpful since we don't always want to load the object context into memory when we instantiate it. Instead, we would like to create it only when it is actually needed. Here is the underlying object, in this case an object context instance. Here we have the method that actually initializes the underlying object context. First, note that it only does so if it hasn't already been initialized, that is, the object context is not. You can see the createObjectContext method is called, and the object context is assigned the result of that method. Now, let's look at some methods a client would call thinking this was a normal object context. First, we have the codeFirstModel property, which, before returning the model, initializes the underlying object context. Then, we have a SaveChanges method, which, if the context is not initialized, does nothing. Otherwise, it saves the changes in the underlying object context.